Let's do Leetcode problem number 15, 3-sum in 3 minutes. Hey, John here, lead maintainer of Latterly. 3-sum is the second problem in the standard Latterly Leetcode Kata, a 12-problem set to help you practice and prepare for technical interviews. 3-sum reads, given an integer array nums, return all of the triplets, the ijk of nums, such that I is not j and k, they're all distinct, and that they sum to 0. Notice that the solution must not contain duplicate triplets with respect to the index. You can have duplicate values. We see in example 3, there's a result that has 3 zeros in it. Example 1, we have -1, -1, 2. So 2 of those -1s, it's okay to repeat the value, just don't repeat the index. We can see in example 1 in the input nums, there are 2 distinct indices that have a value of -1. That's why we're allowed to give that output. So the approach, we can implement 2-sum after sorting nums, sorting costs in log n, time complexity, which isn't binding because we will have an additional outer wrapper. Overall time complexity is O of n squared. Space complexity is constant, O of 1, because we just use pointers. I'll initialize an outer left pointer at 0, and then I'll say while outer left is in bounds, so it's going to be less than the length of nums minus 1. We will calculate the complement, which is going to equal the opposite of the outer left index of nums. Why is it the opposite? Because that way they add to 0. Self.toSum, I'm going to have to implement that. We'll pass in the complement, we'll pass in nums, we'll pass in a list of results. I'll construct results as a set. We're using Python here, so set for auto deduplication of tuple values. So we're going to fast forward duplicates and then eventually return results. Now let me define 2-sum. We're on the solution class, so I'll pass in self, target, nums, results. We will calculate cur_sum. If above target, else if below target. This is just our 2-sum that we're implementing here. Else match found. And to results, and this will be outer left, left, right. It will always be in order. Then we're going to have to fast forward duplicates. We'll repeat this algorithm as long as left is less than right. That's going to be our simple algorithm for the 2-sum. The value of left is that it should be initialized after the outer left. So I need to pass in the outer left as well. Left is outer left plus 1. Remember that we can't repeat that index. And then right will be the end of the array. Cur_sum was pseudocode. The real code is left plus right indices of nums. So I'll update this pseudocode now. And then above target, this is all pseudocode. We're changing it to real code. So cur_sum above target, else if cur_sum below target. If the cur_sum is below the target, then we want to move the left pointer up 1, which will increment the sum, and the reciprocal decrement right if the sum is too large. So how do I fast forward these duplicates? I want to perturb the right or the left. I can do either one. Since we're taking an approach where I move left to right on the outer left, I'll be consistent with that and I'll perturb the left pointer, but technically it could work with the right. We need to pull out cur left. It's just the left index of nums. We'll also do cur right just for code consistency. And so while these values are equal and we're in bounds, then we want to increment left. We can check the in bounds just by repeating the existing boundary condition, left less than right. I'm going to copy that block because I want to do something similar over here. So while the outer left index of nums is the opposite of the complement and we're in bounds, then I want to fast forward on the outer left index. Last but not least, none of this is going to work unless we sort nums, which I saved to the end because I always forget if it's sort or sorted. All right, and that takes care of 3-sum in 3 minutes. Follow for the rest of the Latterly Leetcode Kata speedrun style.